Okay, good afternoon. Welcome to the second class for my session. So today we will be continuing our basic Python. Okay, so refresher for those of you who haven't used it for some time. Okay, so last time we go over some variables, basic variable like integer, float, and strings, and some of the basic manipulation, especially the things that already had the length concept in here. Wait. Did I went through this already? Yes or no? No? Okay, so I already go through just the variable, I believe, just the first file. So this one is the second file, okay? So the collection is a type of data that can be useful when you work with data, a lot of data. And especially in this class, you're going to be dealing with data with lots of rows, lots of columns. So, and it's particularly nice to be able to keep a lot of things into like a single name. And you can manipulate a lot of data with relatively ease if you use the concept of collection. Okay, so the first type of collection that you must have used it before, list in Python. Okay, so I'm going to create a list in Python that contain fruit, right? So for example, I can have the name fruits. Where is my iPad? Wait, something's wrong. I put it here and it's gone. Where? What? Wait. I went here. I think I walked here. Sorry, I have my cheat sheet, and then it's gone. I had my cheat sheet in my iPad, and then it's right here. Actually, this is right here. Without my cheat sheet, I cannot type. I forgot the name. Okay. All right. So. Okay. So here I want to type fruits. Okay. The name is fruits, and I should turn off the AI. Okay. Fruits equal. Okay. So normally you would say fruit equal to like integer, float, or string, right? But then if you want to make a collection of items, then a list would be a square bracket, right? And then inside you will have item separated by comma, okay? For example, I have 3 fruits in here. It would be apple, right? Again, string is enclosed by the quotations, right? And then you will have banana, right? You can come up with anything you want. And cherry, okay. And again, I can run it, right? In order to run it, then you need to make sure that your kernel is selected correctly. Remember that in Python, there are engine that runs the file, right? For the normal py Python file, you have one engine. For the Jupyter notebook like this, you have another engine we refer to as the kernel, okay? So in here, we're going to choose the correct kernel. And the way that I had you set up is that that kernel location is going to be sitting at your user location. So if I select my Python environment, I'm going to choose the one that has this tilde. Remember that I told you that this tilde means that this is the user folder, the home folder. So we're going to choose the one and then followed by the .venv. So that's the default location for our Python interpreter, basically. So again, I'm going to choose this one because this one is for me. For you, it should be your username, basically. Okay. So just confirm with me that you can actually run this one. If you can run this, then it should have, like some sort of indicator that it's running. Okay. And again, if I go to view, right, terminal and new terminal, like last time, I want to be able to inspect the variable in my memory. So I'm going to go to the tab called Jupyter. Okay. And again, you can see that I have fruits, which is the name of the variable. But this time, it's the list. Okay. And then it has a concept of size. Even tells me that there are 3 things inside it, right? And then this is the value. Okay. So yeah, nothing out of ordinary, right? See? Similar to how string works, right? If you have string, for example, I say name equal run, right? And I run it, you can see that the string also have size, right? And last time, I think we spent some time talking about if you have something with size, then you can select some item in it using the index notation, right, with the colon and things that you are choosing except the last one. The thing that I always say that is quite unintuitive, right? Same thing, if you have list, right, fruits in here, and it has size, that means that you can also select the item in it with the same kind of notation that we went through last time. For example, if I want to have the first fruits, right, then I would see fruits, right, and then followed by the square brackets, right, and then the index inside, right? So the index of 0, that means the first item. If I run this one, then you can see that I have apple, okay? So fruits with the index of 0, that's the first item, right? But this one saying that this one, I want to print the second fruits, right? So the index should be 1, like that. So I guess I have this and that, okay? Again, this one is not that confusing, but what's confusing is if I want to choose two things. Remember, if I want to choose maybe the first and the second fruits inside, then the thing that we talked about last time come into play, right? So I guess I'll just replay, I'll talk about it again. So if I want to choose the first two fruits, then I would say that I want to select the first one, right? The first one until the second one. So I mean, I guess naively, you would think that I would have to do something like this, 0 to 1, so the first to the second item. But this one actually going to give me just one item, right? Because the way that Python or the way that the indices selection works is that it's like the first to the second except the last one. So you kind of have to go overshoot a little bit. And I want to say that it's going to go from 0 to 2, which if you read from the indices standpoint, it means that I want the first item to the third item, but then I eliminate the last one. That's why I will end up with two things, okay, like that, okay? Which again, I think, you know, for me, this one a little bit unintuitive, and I came to accept it. I wouldn't say that I understand it completely, but I kind of accept the way it is, okay? Okay, I went ahead of myself, so I'm going to leave it as this one because the instructions say just print the second fruits, right? Okay, so the next thing is I want to add the new fruits into it. Okay, so there are many ways of doing it, okay, but the most common one I would say would be to use this construct. It's called fruits, right? And then dot append, okay? And take a notice into this particular way of writing, okay? I say fruits and then dot, and then there's something happening, okay? And this one will come through it. We'll go through this concept maybe today or next week or next time, okay? So fruit is actually not just the ordinary kind of like thing, right? It's actually an object. Just keep in mind that Python is actually an object-oriented programming. You might have heard of something as OOP, okay? The way that OOP works is that every data type in here is actually an object. And what I mean by object is that it's an entity with action. It can do some action. It's like us. We are an object or entity that we can do action. Like I can walk, I can run. Same thing. This list right here is actually an object that has some action. And that action is append things inside, okay? And actually, you can inspect more action that it can do. For example, if I go back here, right, and then I just do dot. You know that VS Code is smart enough to suggest me the action that this object can do, okay? You can do other things like insert, like pop, remove, reverse source, and the name is pretty self-explanatory, right? You can reverse the list by using the action, for example, okay? So I'm going to choose the action called append. So the first action. And you can see that if the action is valid, then the color changes to yellow. If I were to mistype it, for example, I might add some S in it, then suddenly the color is gone. So that's something to take a notice. For VS Code only, I think. If you use Google Colab, then the color might be different, or it could, this is not specific, this is not universal, but VS Code is pretty smart about it, okay? So I'm going to delete the S, okay? And I just mentioned that this one is an action, okay? The formal way of defining action is called function, okay? So, but right now I'm going to call it action. And in order to do action, you have to do parentheses in order to make the action happening, okay? So I have to do this, okay? And it will become clear when we talk about function, because action is just function, okay? But right now I have to do this parenthesis to make it do something. And inside, I can put whatever I want to add into it. So I'm going to append another fruit, and this one is going to be orange. Okay? Like this. Okay? And right away, you can see that if I execute this particular action, I can see that my orange, okay, goes into the list. Okay? Okay. For those who want a little bit more detail, this action is actually called mutable action. Mutable meaning that it's actually modify the object itself, okay? There are other actions that called immutable action, and it doesn't modify the object itself, but instead it's returning a copy of the new object, okay? If we ever ran into this problem, I will let you know, okay? But there are quite debates among which action is actually more safe. Usually, immutable action is safer, and especially for data scientists, we don't want anything that's mutable because it can modify our original data, which we do not want, okay? And the library that's actually specifically for data science, they are very careful about action that, that can mutate the original data, okay? I will mention this one later, but I would say that this action is quite dangerous, okay? Not here when we can see the data, okay? All right, there are many ways you can do, but append would be the most common, okay? The next stop of the collection is called dictionary, okay? So dictionary is another way of defining, defining a collection of items, but this time the item will come in pair, which is called key and value, okay? Let me show you. Easier to just show you, okay? So I'm going to create another collection called person, okay? This time it will be dictionary, so I'm going to use the enclosing curly braces, okay? Hard to say, all right? So in here, I can define items as a pair of two things. It's key and value, okay? For example, I can name the key name, okay? And I can give the value, which is Alice, okay? And keep in mind that whatever I just put in here, this is one item, one element, okay? And I'm going to separate the item by the comma. So I will put the second item. The second item is age, okay? And then key, and then the value, so 30, okay? And keep in mind that this one, I have two items, okay? And then the third item, the key will be city, and the value is going to be New York. Okay? All right, so if I were to do this and I execute this, this line, then you can see that I have a variable called person. Okay? It is a dictionary, so this person is a dick. That's my joke. Okay? And again, because it's collection, so it has a size of 3, right? Because, you know, keep in mind that this time each item comes in pair, key and values, okay? So it's different from the list, which is just a single value, okay? And then the value is, as you can see here, okay? And again, it's a dictionary because it's almost like when you open the dictionary, which I don't think you ever done that now, but if you open a dictionary, then you will see a key, which is the word, and the value, which is the explanation, right? That's kind of like where this name comes from. Yeah. Okay, so if I have something like this, then again, if something has size, then I can access its item, right? But dictionary is a little bit different because when you want to access the item, you don't use index anymore. You don't use number. You're using the key, okay? So if I want to print the person's age, which is 30, I want to access this value, right? I don't need to use index anymore. I can just use the key. So the notation is similar in terms of I use person, and then I use the the square brackets for the indexing, right? But if it's for list, then I would type in the number 0, 1, 2, something like that. But for dictionary, I have to use the key, right? And again, VS Code is smart enough to show me the possible key because it already know, how this person is defined. So it already know that I have, potential key that I can use are 3 of this, right? It's pretty cool, right? So I'm going to use age, okay? So notice that my key is actually a string, okay? It's not a number, it's a string, okay? And if I were to execute this, I guess I should print it out, okay? I can print it out like this, print, right? Person's age. Then as you can imagine that I do have 30, okay? So that's the way it is. I want you to try, what about if you put the number inside, what happened? You can try right now. If you use person and then in the square brackets you use like 0 or 1, what happened? Try that. And tell me what happened. Right? It doesn't work. Okay, it doesn't work. Okay, so dictionary access the value by key. The number does not work. Okay, so let me hammer this point one more time. So if I were to print person of 0, then it would just give me error. It say that I don't have the key called 0. But you know what? We can fix that. But not really fix it, but we can make the error goes away because there is nothing that prevents us from doing this. Okay, I can do this. If I were to put in another item, like this, 0, okay, and then just whatever, I can do that too, right? See this? I say that the last item in this dictionary has the key called 0. And the value is whatever, okay? And if I were to do this, then I can run this with no problem. See, whatever, okay? So keep in mind that it's possible for the dictionary to have the index of like 0 and 1 as a number, but it's just that you just have to input it manually. It does not come automatically like list because that's not how it works, okay? But there are people who actually construct dictionary that has key as a number, and that's up to you, I guess. Okay, and I want to add a new key value pairs. Okay, so if I want to add the key value pairs, I can just do it here, or if I want to do it later, I can also do it too. I can say that person, and then another key, which is in this one I have profession. So profession, okay. I'm going to set it equal to engineer, okay? And again, this particular line will modify the original data too. Because if I go back here, then I can see that after I run this, my profession, I already have this data happening. Okay, again, this kind of statement also mutate the data too. Is it too small? Okay, you can tell me if the text is too small because all I do is just do this. See? I can always do this too. You want me to do this? It's pretty good, right? Yeah. Okay, and the command is control and plus and minus. Control plus and minus. Control plus and minus to, you can do this in VS Code too. For Mac, it would be Apple, I think. Apple or control, I'm not sure. I have to try. But for Windows, it's control and minus and plus. Okay. So I guess in this class and in most of your Python programming, list and dictionary would be the most common. Okay. The less common type of collection would be the next one. It's called tuple. Tuple or tuple. I think you can pronounce both. Okay. So tuple or tuple. Okay. So tuple is almost like list, but it has some restrictions. Okay. So let me show you. I want to create a tuple, okay, called book. Okay, let's see. Book, right? And to create a collection, a tuple collection, then I would use the just the parenthesis. Okay, and inside I want to have a name of the book. In my example, I use the name. This is too long. Oh, I just type it. The Great Gatsby. It's like the name of the movie, right? And the author of that book is called F. Scott. You don't have to type the same thing as me. Just type whatever, okay? Fitzgerald. Okay, so that's the actual author of that of this book, Gatsby. Okay, and then the date of publication is 1925. So it's pretty old, right? Okay, and I can do this. If I were to run this statement, then I would have another collection called book. And it says that it's a tuple, right? And also, again, it has a size. So again, the way of accessing the data, it's similar to the list. And also the value is here, okay? Same thing. I mean, not same thing, but very similar to list, okay? So if I want to print the name, the author's name, right? I want to print F. Scott Fitzgerald. Then this is second item. Then I can use the index notation. That's going to be index of 1. Okay? Index of 1 is the second item. So I would say print book, but then I could do 1 inside. So right. So for tuple, you can use the numerics index like the list. Okay? If I were to run here, then I can have Scott Fitzgerald as expected. Okay. Right here. Okay, so nothing out of ordinary yet. Okay, so verify with me that you can create a new tuple and you can access the items inside. Okay, very similar to list. But when it comes to reassignment, that's when tuple is different from list. Okay, so check this one out. If I'm going to add a new element to the tuple, like the list, remember in the list, I'm going to use the method called append. Okay, let's see what happened if I were to do the same thing. So I'm going to do books, right, and then append. Okay, as you can see right away that the color does not change to yellow. Okay, and that's a telltale sign that actually this object over here does not have the action called append, because you cannot do that. But I mean, if I want to do it anyway, you know, who's going to stop me, right? So I'm going to do it. Okay, so I'm going to do append, and inside the parentheses, I'm going to add something else like whatever, right? Then what happened? And again, it's going to yell at me saying that, wait, you cannot use this one, right? You cannot append anything to the tuple, okay? So, okay, fine. I cannot add things into it, but I want to change things inside. Let's see if I can change things inside, right? So I'm going to say that, fine, I don't want to do this, but I want to do this book 0, right? I want to change it to something else, right? In list, I can do this. You have to take my word for it. For list, this is fine. For tuple, check this one out. I get yelled at again, right? But this time it says that tuple does not support item assignment. Okay? So the error says what it is right now. Okay? What it's saying is that right now I want to assign this thing into the first slot, and tuple does not support assignment. So essentially, if you create a tuple, you cannot modify it. That's the restriction. That's the difference from list. Okay? And you might be wondering, like, why are we doing this? Like, why would this be useful? Okay? And I would say that it would probably not useful to you right now, and maybe for a while. Okay? But you will come across tuple very quite often actually, because tuple is kind of the default data structure that got returned from the library. Once you start using library and you execute some command asking for some information, if it can, it will return tuple to you. Okay, so you typically don't create it yourself because sometimes that restriction is quite demanding. But if you use library, which I think we will use it today too, then you will get tuple as a return data out of that library very quickly, very soon. So that's why I want to introduce it here, that you treat it like a list. You just don't reassign it. That's all. That's the whole point, right? But wait, but see the last instruction. I'm saying change the year published, right? This is kind of contradicting what I just said, right? Because I'm just telling you that you cannot change, you cannot reassign tuple, right? But I was telling you the last thing, change the year. So how can I do that, right? See, you cannot reassign, that's true, but there's nothing preventing you from recreate the whole thing. You can always recreate the whole thing again. So let me show you this, okay? So if I were to copy the whole thing, right, and put it here, and if I were to change it like 1980, this is actually fine, okay? So I'm going to comment this one out, okay, because this one will give me error. So you have to comment this one out, okay? But there is nothing to prevent me from actually just recreating the entire tuple, right? So this one is allowed, right? See, I don't reassign things. I just create the whole thing. So this one is okay. Okay, so I hope that you make a distinction between modifying the value, it's called mutate the value, as opposed to just recreating the whole thing. That's different. Okay, this one is just reinitialize the variable. But what the restriction is actually you cannot mutate the variable, but you can reinitialize it. Okay, so that's we can do. Okay, and that's it for the tuple. For the collections. Okay, so we just go through this quickly because at least I think you have heard about list and dictionary, and that's what usually you should probably experience it through your Python course. Okay. Okay, so next up we're gonna go through control structure. Again, I believe you have been through this before, so I'm gonna go to it relatively quickly. Okay. So again, if you want to do some logics, then if, else if, and else would be your go-to choice. Okay, so I'm gonna write a little program that can take your user input. Okay, so nice trick. If you haven't heard of this, you can have something called input. Okay, input is a function. We'll go through that soon. Okay, it's a function. This one is actually gonna accept the user input. Okay. So if you type like this and you hit enter, again you have to select the kernel, okay? And it's going to ask for user input. See something right here? That's where it is. So if you run this cell, it's going to ask for user input. And then you can actually input something inside and press enter. Okay? So try that. All right? So I'm going to put something in here, right? And then hit enter. And I got something in here. Okay, so try that. If I execute this particular block, I have to type something in here on top, okay? Type something in here, and it just appears right here. So that's accepting the user input, okay? That's called input command, okay? So what I want to do is I want to, and again, if you type in some strings in here, then it will be kind of like a little instruction for the user. So I say enter a number. Okay. If I run this statement, then I will also have a little instruction in here, so the user know what I should do. So let's say I input 10. So I get a number like this. Then I do have a number. Okay. So string inside, it's just an instruction to the user. Okay, so what I want is actually I want a number. But notice that if I were to do like this, then whatever appearing at the bottom is actually string because there are this little quotations in here. So that means that even though the user input a number, it's treated as a string. So what I want to do is I want to make an integer out of it. So I'm going to say int and then surrounding whatever the input is. So notice that I can change the variable from string to integer by using the int command and then enclosing the input statement. So right now, if I were to run this thing again and then I type like 100 or 1000, then the return type or whatever showing here is actually a number. It's no longer string. You don't see the quotation anymore. Okay, so that's the reason for doing a lot of enclosing parentheses, because I want to change whatever the input is into number. So right now, if the user typing a text, then it won't work. Let me show you this. If I run this and then I type in the text, it doesn't work because you cannot convert the text into integer. So right now, this program is a little bit fragile. Okay, but just type in the number, shall we? All right. So I'm going to say that whatever the user type in, it's going to be equal to num. So right now, I store the user input as a number inside a variable called num. Okay. Then I can do something with that number. Okay, I'm going to say if number larger than 0, okay, and then it's going to be followed by the colon, right? And right after, you're going to see that if you do the enter, new line, then the editor automatically indent for you. So this is something, you probably have encountered this before, right? It's creating a new block, right? So if loop saying that it restricts certain condition to go through a certain block, and when you define the certain block of code, you have to indent it so that it has some separation from the main code, okay? So this one, the indent is automatically and intentional, okay? So right here, I'm going to say print, okay? And then I'm going to say that positive, okay? So I can have the program that print positive when the number is positive, right? And I can also do another else if, right? Else if num is less than 0, and again followed by the colon, right? That signal the beginning of the new block. And then once I hit enter, the indent is intentional and automatic. I can print something else like negative, okay? And then I can do else, right? And then followed by the colon. And then if I do another new line, then it's automatic indentation. Again, intentional, right? I'm going to say print 0. Okay, so I hope that you have been through this type of construct before. Although if you haven't typed it too much, then you could make some syntactical mistakes. But essentially, this is what it is, right? So you define a logic where different type of condition leads to different type of execution. Okay, so you can try it around. You can try if you run this block again. Then you can input something positive. It will just say positive, right? And then if you do negative, it will say negative. And if you do 0, just say 0, okay? And that's the if loop for you, okay? Okay, and if you're feeling more adventurous, you can do something else, right? You can have more lines of code, right? You can print something else, right? Print Yeah. So take a notice that as long as it's indented, it will belong to that same blocks of code, right? No. See? So I don't have to do just one line, right? I can just keep, the code in the same indentation, and that's going to be the same block of code that get executed. For example, this 2 line, it's going to get executed when the number is larger than 0. So you can have a very, very long blocks of code as long as you indent it correctly. Then then you can just defining whatever sub programming sub execution task to your heart's desire. Okay. All right. So if loop, very, very common. Another thing that will happen very common is for loop. Okay. So for loop is when you have to do something repeatedly, and computer is very good at doing something very repeatedly. So let's do that. Okay, so I'm going to print a number from 1 to 10 using the for loop. Okay. So the construct is for. Come up with called a dummy variable, usually I. It can be anything, right? In something, something. Okay. Okay. And then I want to make sure, want you to be aware that whatever I put in here, it has to have a special kind of behavior. It's called iterator. Okay. Iterator is something that can split the value sequentially. That's called iterator. Okay. And one iterator that you're always going to use, during the first, you're learning of Python is called range. Okay. So range, right here. Range. This is kind of like a function that returns iterator that you can specify, what kind of sequence you want it to do. Okay. So the easiest one would be if you do from 0, okay, to 10. Okay. So very, very, I guess very intuitive, right? I want to go from 0 to 10. Okay. And again, it's going to be followed by the colon. And that's the indicator of the block that it's going to be. So if I do the new line, it's going to indent automatically. So whatever's inside, you can do things repeatedly. So what I want to do is that I want to print I. Oh, I misspelled. Okay. And what's going to happen is that it's going to go through this loop, the number of times. And each time, it will execute this line, although the I will change according to whatever the iterator is splitting out. Okay? If you run this, you will find that it's not doing what the instruction is saying. Right? It only print up to 9. Right? See? It only goes to 9. Okay? And you might be wondering, wait, I just say going to 1 to 10, right? 0 to 10, right? So why don't you print the last one? And again, it works the same way as when you select things inside the string or list. Okay, so it's going to select from the first one to the last one minus the last one. So it's going to take the last one out. So again, the same thing. I'm going to select from 0 to 10, but it's going to take the last thing out, so you only get 9. Which again is very unintuitive, but I just came to accept that that's the way it is. So if you want to print 0 to 10, you're gonna type 0 to 11. Okay. Okay. And if you want to blame the guy who came up with this. Okay. Don't blame me. I don't know. This is how it works, man. Okay. Okay. And as you will see, okay, range, it's not the only thing that you can put in here, okay? Anything that can split the value in sequence called iterator, you can put it in here, and it will loop, okay? Anything. If I can come up with it, Another thing that can split things in sequence is list. Let's try list, shall we? Instead of doing this, oh, okay, I think I'm getting ahead of myself. Okay. Okay. I'll go to that later. Okay. Oh, actually, I don't have anything else. Okay, so let's do this. Okay. Another thing that you can do is list. So let's check this one out. For I in range, not range, but list. Print I. Okay, but right now I will say fruit. Not fruit, but apple, remember? Banana and cherry. This is a list from last time, but this one actually works because list also can function as the iterator. It can split things in sequence. So try that and see what happens. Okay? And as you will see that it's actually printing the actual things inside the list. Is that pretty nice? And we use this a lot actually, okay? Again, this one is fine, but if you want to make things even more readable, maybe you should change I, because I know that I is a fruit, right? So why don't we just change it to make it like English? So I'm going to say fruit and print fruit, okay? So this one even more readable, okay? You know what else is iterable? Dictionary is also iterable. So actually any collection is iterable, okay? Iterable. So let me show you dictionary this time, okay? Okay, so I'm gonna do this, okay? But this time I will do for, okay? I just I first, okay? In, and now I will do dictionary. So, but dictionary is kind of long, so I'm gonna define dictionary first. So person equal, remember, I'm gonna do name, right? And just do Tom, and then age of 30, and city, right? City, New York. Okay, so just come up with whatever dictionary you want, right? And I can also for I in person. I think it will give me error. But I want you to try first. I think I will get error. Okay. Okay, let me try. I don't think I can do this. Whoop, I can. Okay, so I was wrong. Okay, but there are a little fine print more, but let me explain. Okay. Okay. So right now actually works, but not the way that I expected. Okay, because you know what? When I iterate over the dictionary, each of the item there are two things inside, right? There are key and values. So right now, it's actually iterating over the keys, right? It's actually iterating over the key. That's why I get name, age, and city, right? What if I want this guy? I want Tom, 30, and New York, right? How do I do this, right? Actually, there are better ways. So this person, if I do dot, you will see that there are many actions that it can do. I want the action called value, this one, this guy right here. But then when you have action, you have to execute that action. So I'm going to do parentheses. And check this one out, person.values. There you go, done. So the action called value is giving us the iterable that you can split out the value in sequence, okay? And you can, as you can imagine, that actually a better way to split out the key would be to use another action called key. We can find it too. Let's check this one out. I'll go back here. Where's my key? Right here, key. So the key is another action that you can call. Don't forget the parentheses, and it will give you the iterable that you can use to show the sequence of keys, like that, see? So normally I would expect something like this, but I wasn't aware that if you just do just a person, also the same as the key, right? But what if I want two of them? I want both, right? Actually, there's another action that gives you both, okay? Let's check this one out. Where is it? Dot. This way. Items. If you do dot items, then it will give you both. Okay, let's check this one out. Both, okay? And then don't forget to execute that action, okay? There you go. I get both. Okay? And to be even more, to relate this to the collection part that we just learned, you know what I just got? I just got something that is a collection, but it has the signal, the notation of a parenthesis, and that is called tuple. And again, I was saying to you that you will encounter tuple very early. I didn't think that it will be this early though. But yeah, this is the first thing that you get from inquiring the dictionary's item. You get tuple, okay? And again, you don't even need to do, I mean, the whole point of this is that you can use it. You don't really need to create a tuple, but you just got it from, for example, iterating through dictionary. You get the tuple, okay? And again, if you want to print things out, in a separate item, then you can do the indices notation. Like you can do I of 1, right? Sorry, I of 0, and that will give you name. You can do I of 1 to give you the key, the value, right? So again, it's a collection, and you can access the value using the index notation. Okay? Something like that, okay? And just to kind of hammer the point home even more, actually the string itself is actually iterable, okay? I can say that for I in A, B, C, I can print I, and it will work, see? Even the string itself is actually iterable. Like the actual item character in the string can be iterated too. Okay, so there are a lot of things that you can put into the for loop as long as it's iterable. Okay? You don't know this unless you've seen it. So yeah, you have seen it now. Have we? Okay, you need the colon too. Okay, don't forget the colon. Okay, and lastly, the while loop, okay? And to tell you the truth, I never use while loop, like almost ever. Like in my, I guess, the many years of programming in Python, nope. Okay, so yeah, you probably won't use it that much, okay? But it's there for, in case you need it. So while loop is a loop that can do, keep doing it, repeats until some certain condition is false, okay? So usually it can do something like count equal 5, right? And then if I want to print, then I can say while count is larger than 0, right? I can say print the count, okay? I mean, you can read it like English, right? While as long as count is larger than 0, just keep printing it, right? But then you should have a condition where this thing is eventually going to be false. So if I'm do count equal or shorthand, which is minus equal 1. So decrementing the count value every time, and then eventually the loop will stop, okay? Like that. Okay, so the reason that I usually don't use the while loop, because in my career as like working in the data science, the number of things that I want to loop is always known. So it's better to use for loop, because in the while loop you can run into the situation where the loop never stops due to your error, and I just hate that. Okay, so I never use it. Okay, but it's there if you ever need it for some reasons. Okay. Okay, we spent an hour, so We should have function. Okay, I'll give you 5-minute breaks. Okay. Okay, so let's continue, shall we? I'm going to go through the next one is function. Function? Okay, function mean listen to me, you know. Okay, all right, so function is something that I referred to just previously about the action. Actually, the formal name is function, okay? So the function is a way for you to define a block of code that you can execute whenever you want, okay? And that's very convenient to make things concise and, you know, reusable. Okay, so let's create a simple function that says hello world, shall we? Okay, so in order to create a function, you will use a keyword called def, okay? And the name of the function, you can create your name, anything you want. I say greet, right? Followed by the parenthesis like this. Okay, so that's how the function definition works. And you end that definition, declaration with the colon. Okay, so similar to how would you do the if-else loop, right? For loop and while loop. You're going to end the first line with the colon. And after that, the indent is automatic. Right? And then you're going to type in anything that you want to execute within that block of code, right? So I'm going to say print hello world, right? And like that, okay? And that's it. That's all you need to do in order to define a function, okay? And again, if I were to run this, again, you have to select the right kernel, okay? Then, and even if I inspect the variable tab, you will see that there's nothing coming, like there's nothing in here, right? There's nothing in here. But even though I just execute it, right, it's nothing in here. And that's normal because this tab doesn't really show the function. It only shows the variable. What you just did up here is called function definition. It's actually in your memory though, but it's not shown in this particular tab. So don't expecting to show here, but if you executed it, it's already in your memory, so you can use it, okay? So how do we use it? So right now, if I run this, then if I inspect, you know, what's happening down here, then nothing gets printed out, and that's because this function or action hasn't been used yet. If you want to use it, you can use it in the main blocks of code. I'm just saying, maybe I'll just create a new block, right? And then I'll just say greet, and then followed by the parenthesis. So this is similar to how I would say, like, this is the action. And if you want to do the action, you do the parenthesis. It's called the function call, okay? I'm calling that function. If I run this, then I say, I get hello world, okay? So again, I run this on the second block. You know, it's not on the first block, right? But I already run the first block, so the program already know that there is this particular definition in here. And then once I run or execute that function on the second block, then I get hello world, okay? So notice this behavior though. I want to just keep in mind, want you to keep in mind that if I were to clear the whole memory, and I can do that, okay? If you want to clear everything, then what you want to do is this button right here, restart, okay? So this button clear everything. So why don't we clear everything? And I'll show you this behavior in case you ran into the problem, okay? So I'm going to restart, and then it's going to warn me that if I do this, then everything's gone. And yes, I want everything to be gone, so I hit restart, okay? And now keep in mind that even though, you know, I have all of this printout, it actually means nothing. Like I have nothing in my memory, okay? And if I were to come here and just execute the second block of code, I get error. And it was saying that it doesn't know what greet is, okay? Does this make sense? Because you haven't really run the first block, right? The first block defines what function greet is. And now if you run it, then you can use it. But if you clear everything and you came straight to the greet part, then it doesn't know what greet is. So you have to run the definition first, even though it doesn't really appear on the variable pane, okay? So make sure if you see something like this, then you're aware that you're missing the running of the function definition, okay? And again, I can also clear the output, right? I can clear the output, and then I can do it again. It doesn't do anything, right? As long as if I don't come here and run the first block, and now I can execute it, okay? So that's something. So I mean, for me, when I run, like a file like this, it's always a good practice to run from the top to bottom, okay? And after some time, you will find that this button is particularly useful. This one, run all. This button is extremely useful because if you hit this one, it always gonna re-execute everything from top to bottom. So anything that you change up there and you forgot to run it, it will just re-execute it down. So this is my friends. I run this all the time, okay? All right, that's the first thing. All right, so what about function that is actually smarter than this, right? So this one is okay, but no matter how you run it, it's gonna do the same thing, right? So let's do a function that's a little bit smarter, okay? So this one is a function that adds number, okay? So I can do def, right? Add number, okay? And then something, 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 right? So in here, it's a little bit different because if I want to add number, then I should give, whatever number I want to add into the function, right? So right now, if I just say, just add a plus b, right? Then it's going to yell at me because it doesn't really know what a and b is, right? So I have to tell Python that, this a and b will come from outside. So you can think about whatever here is like inside, right? A and b has to come from outside. So we're going to put a and b in the function definition, meaning that I expect this a to come from outside, and a is going to be this a, right? Obviously. And this b also is going to come from outside, and this b is this b, obviously, right? Something like this. Okay? And maybe first I'll just print a plus b first, like this. Okay, all right. So that one works, right? Okay, if I run it, then yeah, I can definitely, there's no problem, right? Okay. And what if I use it? What happens if I try to use it? If I just do add number and then don't do anything to it, just kind of run it as I would do previously, then what happens is it's going to yell at me now. See, it's going to yell at me saying that, wait, you define the function expecting two things from outside, but when you actually running it, it's not matching, right? You need to supply it two things, okay? And these two things has to be the actual value, right? You cannot just do a and b in here. This one doesn't work because what is a and b, right? You don't know what a and b is, right? So from outside, you got to do like real number, like 1 and 2. And if you run it, you get 3. Something like this, okay? So there are names that are ways to call all of this, okay? The first thing is a and b. In here, it's called function arguments, okay? And what you put in 1 and 2 is called parameter, okay? So there are like formal name for it. So function arguments, and then the parameter, okay? That's if you ever, hear me calling this name. So keep in mind, that's the argument and parameter, okay? Okay, and there is nothing to prevent you from adding more arguments. So argument meaning the one on top. I can do ABC if you want. Okay, if I want 3 arguments, I can do ABC. And I can use C anywhere I want. For example, I can do A plus B plus C, right? But here, if I come down here and I only have 2 things, then it will yell at me saying that what you define as the argument doesn't match the parameter that you're given. Okay, so it has to match. Okay, so I have to do 1, 2, 3, something like that. Okay, so just keep in mind that whatever you define, when you use it, you gotta have to make it compatible, okay? Okay, so this one is good and all, but we're going to make it even more useful, especially for functions that do calculation, because printing things out, it's not that useful, right? We want the results back to the main program so that we can use it for further processing and visualizations. So we don't want to print, but what we want is actually return. I want you to return your calculation. So instead of printing, which is kind of useless, right? I want to return A plus B plus C. So that would be a more useful construct for the function that do calculation like this, okay? And again, if I were to do add number, right now, it would feel the same, right? It just prints 6 right here. But that 6 is actually different because this is 6 because the last line is actually returning a value, not because it's printing out. So in Jupyter, whatever you put on the last line, it will print it out if you return the value. But the difference is like this. If this thing is actually returning a value, I can capture it in another variable. So I can always say result, right? Result equal. So I can do that because now the function is actually return a number back. So whatever returning from this function will get adding to the result. So this is a different. I can capture the results from the function. So that's what I mean by returning type. Okay. And then again, if I do this, then it will stop printing out the value because this statement does not return anything. But I can always just type result at the last line so that I see whatever it is. And again, result is another variable that I can use later on. So keep in mind that if I don't return anything, actually this one will do something too. If I do like this, what do you think will happen? You should try. What will happen if I do this? I don't return anything, I just print it out. But then I keep all of this variable similar to what I had before. What will happen? Okay? The code will run, right? It will run. But now it's different because the value of the resource is different. Let me show you this. If I go to the view and terminal, right, and I go to Jupyter, see this one? None. See what none is? None is nothing, okay? Does it make sense? Now my result is nothing. And if you write a code and your result is nothing, I think that's the bug in your code, okay? And that's a pretty easy to encounter bug though. When you write the function and you forgot to return it and then you set it into another variable unknowingly, this thing will become none because it doesn't return anything. So something easy to miss, okay? So keep in mind that you had to return something. You want to capture the value. So I change it back like this. If I run it again, this is something that I want, right? Okay, so keep in mind. Okay, so this is good and all, but I'm going to step the games up a little bit just to make sure that you know how the function is usually written in a more formal manner. Okay, so let's say that I have another function, okay, called describe pet, okay? And then, first of all, I would say I have pet name, and I have pet type, okay? And for simplicity's sake, I just want to print it out, okay? So print, okay? And then I would say, first, I want to show you, maybe a good place to show you the F string, but from now I'll do this. I have a, right, plus meaning that you do string concatenate, right? I have a pet type, right, plus dot, oh, sorry, name, name plus, and then pet name, okay, and then plus, and then dot. So in a way, I'm trying to construct a sentence out of the two things that I have, okay? And keep in mind that I have to have a space, because then if I don't, then my pet name and the article will be next to one another, right? And again, I have to have this space before and after the word name, so that it's separated by space, right? So it's a little bit convoluted, I would say, but manageable for now. But I just want to show you that it works first, okay? Okay, so let me use it. So describe pet, right? I'm going to say pet name is going to be equal to my dog name Sunny, right? And pet type would be a dog, something like that. So if I were to run this, yeah, I have a dog named Sunny. So yeah, works. Okay? Works. Okay, so it works and all, but this is actually not the way that I would recommend you define this function, okay? So if you define a function like this, then I have to remember that the first parameter is going to be the dog name, the pet name, and the second parameter is going to be the type. I have to remember that. If I were to use it incorrectly, then what happened? You're going to see this. So comment this one, and I'm going to do another one, but then let's say I forgot. I just say dog first and then Sunny, right? And you're going to see right away that now my the output is incorrect, right? So I mean, this is for just 2 arguments, right? But in the real function, in the library, for example, there are maybe like 20 arguments that you have to use, and it will be impossible to remember the order of the argument or the parameter, right? So a better way is actually to use the keyword argument, okay? So let me show you this. So instead of typing just regular things like this, I can do this. I can say that pet type equal, and I can say pet name equal. See this? So this is another way of doing. So let me just do it. So the way that I do not recommend typing this is just input the parameter like this, okay? But I would recommend just putting in the name of the argument in here. So if I do this, then my output is correct, even though the order of the information is actually reversed. So actually, the name of the keyword arguments has to be the same. So for example, this one, this pet name and this pet name, it has to match, right? Again, pet type and pet type has to match. So if you were to go back to your function and you change it, let's say you, I don't know, for some reason you have s in here, you can see that this one doesn't work anymore. Actually, this one doesn't. Okay, so I don't want to change it too much, but if you change all of this, you have to go back here and change it too. So that's another thing to keep in mind, that all of this name, it has to match. Okay. Okay, this is good and all, right? But what happens if I do this? If I don't do all of them, right? Describe pet and then pet name equal Sunny. Okay, I just do one parameter, right? What happened? Do that. Okay. So again, this one kind of relates back to what we just talked about, that if the function arguments require two things, you have to put two parameters in here. So right now, this one is only one thing. If you're missing some of the parameter, then yeah, it will throw you an error saying that you haven't given them enough information. Okay. So this is all right. But then there are many situations where you don't want user to input everything because a lot of things are default by design. Okay, so for example, maybe 99 of people in the world owns a dog. So then the type is mostly just dog, right? So then you don't want user to be typing dog if there are just the like a very common input, right? So I can do this. I can say that pet type equal dog. So notice the difference here. Now I put the value inside the argument, the function declaration itself. Okay, and this is called the default value, meaning that even though the user doesn't tell you the type, right? It's gonna default into this dog automatically. So right now I can run this thing, and it will use the default value here. Okay, so that is extremely useful when you define a function, or maybe not you, but as the author of the library that you are using, one function can have 10 or 20 arguments, but most of them are default. So all you need to do is to use the one that you want. The rest, just leave it as the default. So make your code very readable. Okay? And there is nothing to prevent me from override that default. If I happen to own a cat, then yes, I can just say pet type equal cat. Maybe something else like Mary. See, I can override the default whenever I want. So this is a very common pattern when you use the library, which is if you look at the documentation, that function will have tons of arguments. But whatever you're using in reality, it's just a little bit of things that you just want to override. That's all. Okay, so extremely useful pattern to notice. Okay. Okay. So once you learn all of this, now it's time to put things into use a little bit. Okay, I want you to try, and this time I want you to try without the AI. So try without the AI first, okay, and see if you can come up with a way to solve the problem. Okay. I mean, if you use AI, you can just get the answer right away. So let's attempt to do the first thing. So again, this is the data. Okay, so right now, if you see all of this character, you should be able to see that it's a collection of some sorts, right? But it's the collection embedding into another collection. Okay. First of all, the outer collection is what? If I collapse this, what is this? It's a list. See, so the outer collection is a list. Right? What's inside? There are stuffs inside. This is one item inside the list. This is another item inside the list. It's a tuple with the parenthesis. So it's the list containing a tuple, okay? But what go inside the tuple? There are number, string, and what about this? Curly braces with key and value pairs. Dictionary. So see this data structure contain list of tuple of a bunch of things, including dictionary. Okay, so I mean this is quite overkill. You know, normally you don't have to design something like this, but for practice, okay? So we're gonna use this data and you're gonna try to manipulate it as follows, okay? So first, can you think of a way to write a function to average the grades, okay? I want you to try first without the AI, okay? And then I will show you how I would approach it, you know? And then after that, you can use AI, okay? But try without the AI first. So what I want you to do is write a function that if I do average and then the student is the whole thing, the list, right? It can take, sorry, take the student tuple, okay? So the student tuple is this one right here. This one. This is the student tuple right here, right? And then it returns the average grade. So each student has 3 courses, right? Math, English, and science. I want you to average all of this. Okay, so the function takes in the student tuple. Tuple is a parenthesis, the pink parenthesis, okay? And it will average the grade of the 3 courses, okay? Attempt first, okay? You don't have to finish it, but attempt first. And the most important thing is how you would approach it. And I want to show you how I would approach it, right? And then after that, you can ask AI because it already gives you the answer, right? But first, approach is the most important, okay? Okay, so normally, you know, if you first, you know, learning, you know, programming and stuff, you know, there are many things that, you know, it might seem hard to get started right now because I've seen most of you usually have a couple lines, but haven't, you know, come up with kind of like a way to start yet, right? So this is how I would approach it because this thing, I mean, this is a main multi-step problems, right? And there are, usually when I tackle this type of problem, I'm trying to go for the kind of like the simple puzzle pieces, right? So what's the simplest thing that I can do without all of this complicated constructs? First, I think function is quite complicated. I'll get rid of that right away. Like I don't want to start my solution with function because I see most of you start with def average, right? I would recommend against that because function is abstraction. When you want to work on your problem, you want to be as explicit as possible. You don't want to abstract anything. So I recommend not using function. And again, if you read it a little bit more, then you will see print all average grades. That means you are trying to loop it too, because if you want to print everything, you usually go through the loop. And again, looping is also complicated. I would advise against starting with loop. So trying to do just one thing. So break down the problem into first, I want to calculate the average grade of just one student. How would I do? No function, no loop. If I were given just maybe the last guy, Tina, right? How would I calculate the average grade? Okay, so I want you to try again, but this time, can you start from this? You just copy this one and do this. Student equal that. And from here, can you attempt one more time with me? Can you calculate the average grade of this student for me? Forget about function, forget about anything that the problem is asking. I just want average grade of this one person right here. Okay. For example, if I give you some hint here, so I think some of you got it because some of you try to do this, right? Because you notice that, wait, student is a collection, right? And then you want to access some item. So maybe we can figure it out. We can just try it. Like, okay, what about 0, right? If I do 0, I actually have to run. You have to run the first block first, okay, to get the, or actually you then have to do it, okay. So if I do student of 0, wait, I get 20. Wait, oh, that's the first item, right? If I do student of 1, then I get the name, right? But if I do student of 2, what happened? Whoa, I get all of this. See, I come to the right place, right? I got the number. So actually, so this one is a bit complicated because it's the nested structure. But essentially, if you say student with index 2, what you got out is dictionary, right? But I just want the number. So then it's the way of accessing the value in the dictionary, right? As I was mentioning, we don't use the indices anymore. We use the key. And the key is math, English, or science. So maybe we'll just try with this, okay? And with the key. And you know what? VS Code is even smart enough to suggest that these are the key that we can use. So yeah, why not do math, right? And right away, see, I got 81. And now, if you got this, then you can work backward, right? Okay, I got the first number. How do I get the second number? How do I get the third number? And now I can calculate the average, right? Okay, and we don't even talk about function yet. We don't care about function right now. We just want to get the average of one student. Right, so okay, let me show you a little bit further. Okay, so if I want to get the second number, then maybe I can just copy this one like this. And then I would just say English, right? And I would just say science, right? So right now I got 3 numbers, right? And now I can start to do some averaging, right? Okay, so maybe I can do average equal, right? And this one, let's do this. But it works. Okay. All right, so without taking too much time, because we have some stuff to go through, but see, this is how I would approach this problem. So I just want to boil it down to the simplest construct that you can have. So the simplest thing that you can do with the average value without like completely hard coding it, then would be something like this. You have student 2, meaning you access that dictionary, and then 3 different courses summed together and then divided by 3. That would be your average, right? Okay, I got 1 student, right? Now it's time to wrap it up in a function, right? Because now the function is just the top that has a definition and whatever the input that we need, and the rest just go into the block, and that's quite easy to do. Once you have this one, making this into function, it's just a matter of get rid of the input on top and then make it into the definition. So right now, I don't need the input because the input will come from the function. Okay, I don't even need to print them out, right? And actually, I don't even need to print this one. So actually, maybe I need to print it, but all I need to do is just to def, right? And then average grade, which I mean, I should not have the same name as this. So I'm going to change it back to rest or something, right? And then I want the input of me to be student. And then the rest, I'm just do that. Okay, so that would be something that I can build off. But see, the beginning is important. Like, how would you boil it down to the simplest problem possible? Okay, so you'll have more time to practice like this. And I think it's important for you to not use AI right away. Okay? So we can test this one too, because now if I were to give my student, so let me use this one. Okay? I want this student up here, down here, and I can call my function, so average grade of student. Then I get my average grade now. Okay, so something like this, okay? And then once I get the function to work the way that I want, the rest is to make it into the loop if I want to print all the grades from the student. And this one, I would say that required a little bit more thinking, but now you get the building block, right? So if I want to loop this thing, again, I want to make sure that I can access the student, right? So first, I show you that if you have a list of stuff, it's iterable, right? So I can loop through everything in this list, okay? Let me show you this. I can say for, right, I in student, okay? I think student with S, right? Yeah, student with S, okay. Okay, and then when I loop something, I usually just try to print them out first, just to check if it's the right one or not. So I'm going to print I. And again, if I print it, then yeah, it's a tuple of the student, right? So the rest of the things that I should do is actually to execute this line right here. Change this to be I. And now I got all the grades. Okay. Yeah, but I agree that, I mean, I've been through this a lot. That's why I kind of know how to approach the problem like this. But you do have a lot of problems to work at. So for example, with this, then you can kind of see the next one and the one after it, right? So if I have time, which I start to not have time, I will come back to here, okay? So that you know how I would approach. Maybe I'll just do another one for you, okay? But this time, I'll just show you right away how to do it, okay? So the next one is to create a list of tuple, okay? With student ID, name, and average grade for all students. Again, if I were to get a list, I don't want to get the list. I want just create one thing only, right? If I want to get one tuple, okay, with the student name and student ID and average grade, then let's say if I were given, again, this guy right here. If I got one student. See, I always start with one student. So one student, okay, like this. And I want to create list, tuple list, like, okay, tuple, okay. tuple, student tuple. How about this? Student tuple, right? I want it to be equal to the student name, student ID, student name, and average grade, right? So the name is here. So I want to get this thing in here. So I think we've been through that before. The second item in the tuple can be accessed by student of 1, okay? I can even print it in here so that I can keep track of what it is, okay? So print student tuple, okay? If I do this first, wait, yeah, I get Tina. Okay, so this is good, right? The next thing I want is, wait, I got student ID. So student of 0, right? So that's the first item. Okay, now I got student ID, I got student name, but I need to have an average grade, right? So the average grade is something that we had on top. Because on top, we already have the function that if you input the student, it output the average grades, right? So I can just use it. So I'm going to do average grade, okay? And then followed by the student itself, okay? And that way, oh, actually, I forgot to return. Yeah, this is quite important. I need to return rest, okay? If I don't return, I cannot do this, okay? So I have to return it. But again, if I can do this, then yeah, this is how I would get one thing, right? This is just one thing, one tuple, right? But then the instruction was saying that I need all the students, so that means that I need to do the same thing, but I need to loop it. So I'm going to put this thing into the loop, okay? And that would make things easier to reason about. So in order to loop, then I don't need this thing anymore, but sorry, actually I'll just do like this, right? I want to loop through the student. So again, for I, and I'm gonna call this one student because it makes more sense in students, okay? And inside here, I'm gonna copy this one in here, and that's it. I can do it now. So I can print student tuple, okay? Something along that line, and then I can get the answer, okay? Yeah, which I don't think I want to print this one out. So let's not print it out. Okay. Okay. Okay, something like this. Okay. So this is part of your homework too. Okay. So as you can see in your Mango, I put in kind of 2 more examples of something like this for you to practice on. Again, I mean, I cannot enforce you not to use AI. So if you use AI, it will print the answer out right away. And the answer will be super optimized too. Like the code will be super nice. As you can see that the answer, this is the way that I write it, right? I write it like this, right? Like this, right? If I use AI, actually, I actually use AI in my solution. So let's check it out. My solution looks like this. Right here. Good job. Yeah, this is what the AI answer looks like. Okay, so I mean it's super optimized, and I mean even the this is the one with the second answer, like so. I mean, for me, if I know you're a beginner, and then you give me like this, I would know that you will use AI. Like I know it, but I cannot enforce you, right? But I want you to learn. So, for your own good, okay? Do not use AI just yet. Try first, okay? And I can promise you that you'll learn a lot, okay? So don't use AI just yet. But if you get stuck and you ask AI, you should try to understand. But this one is pretty optimized. I mean, it's in your, you can download my solution, so don't worry. But, you know, and again, I mean, I guess for your homework, right, I cannot enforce you. Like, so if you send me the correct answer, I am entitled to give you the full score. So that's okay, right? But in your project, if you show me your code and it looks like this, then I will ask a lot about how you would come up with this. So be prepared to explain your code, okay, in your project. Okay, so I expect you to understand it, okay? So do not just copy and paste your code and show me it, okay? So that's my way of trying to force you to learn, okay? And see, like this is the AI answer for the third problem. Like, yeah, like what is this? Enumerate. Like if you do see this, you should try to understand what it is, okay? Okay, so I have half an hour. So let me continue, shall we? Okay, because I have so many things I want to cover, okay? All right, so the next stop, it would be classes. Okay, this is going to be fun. Wait, have you learned about classes in your Python class? Yes? Yes, okay. That's much better. Okay, no, it's okay. I'll assume you don't know about it. But this thing is very confusing for the first time. If it's the second time, I'm sure it's better, okay? Okay, again, I mentioned to you that Python is an object-oriented program. That means that everything is a class, an object, right? It's not just a piece of data. A class or object is an entity that contains other things. One of them is action. Action is actually a function, okay? Another thing is that object contain data, okay? It's called attributes, okay? So there are many names referring to whatever the object contain, either data or attributes, or function, or action, or methods. So there are many names, and I'll refer to them interchangeably from now on. Okay, so let's say in the object-oriented programming, there are two concepts that you need to understand and distinguish between the two, which is class and instance of the class, okay? First thing, the class, okay? So the class is like a blueprint, okay? Blueprint meaning it's a plan for creating something, but it's not actually that something. It's not tangible. It's just a concept, okay? So let me create a class called my class. So I'm going to say class, my class. And the convention is to use the capital letter for the name of the class. And again, it follows by the colon, okay? And if you hit enter, then it's indented automatically, as usual, okay? And in this class, I am free to define whatever this class will encapsulate. The encapsulation is a concept where you define something that contains something, like action or the data, right? So this one, I'm going to contain x, okay? And this x is going to equal to 5. That's it. That's the simplest blueprint that you can do, okay? And again, this one, it's not even a thing yet. It's not tangible right now, okay? If you want to, that's my clue to quit. But I still have time, right? Yes, okay, I have a couple of minutes to go. 20 minutes at least, okay? Okay, so if I want to get something tangible from this blueprint, then I have to create what's called the instance, okay? So there's a class, an instance of the class, okay? And I want to show you this, again, might make you understand this more clearly. So if I go to my terminal, and then go to, where's my Jupyter terminal? Okay, let me run this one once. I have to run it. Yeah. Okay. Notice that if I run this, there's nothing happening here, right? There's nothing on my variable. It's like function. Like when you run the function definition, there's nothing appearing here. It's not a variable. It's not tangible, okay? But what happens if I create an instance of the class? Let's say I do this. I come back here, and I say P1 equal my class. But not just this one. I'm going to do this. When I do the parenthesis, I'm saying that I want to create an object or an instance of this class, okay? And notice that once I execute this block, see, I got something that I can look at. It's tangible. It's an actual variable, okay? And this variable has a particular type called my class, see? So again, the type of the variable is actually the class definition. And actually this one applied to even like string, float, list, dictionary. Everything in Python come from the class definition, okay? Okay, so I might go too far, but see, right now my P1 is an instance of the class, so it has to have this thing inside because the class encapsulates data and action, okay? So I can always access whatever my X is. So if I do P1 and then I do dot, do you see this? VS Code is smart enough to know that inside P1 there is a data, or I should say more formally, attributes called X, okay? And what would that X be, right? You can try that. If I hit enter, then you get 5, okay? I hope this is expected, okay? Because we just defined up there that X equal to 5, okay? Something like this, okay? And another thing that you can do is I can create another instance of the class called P2. Let me just do this. I'm just doing another block, right? P2, right? Equal my class. And if I were to run this, then you see that I get another tangible object called P2, right? Same type. And if I were to print or even just type P2 dot, then again P2 has X. And what would that X be? You know, what else can it be apart from 5? They all have X equal to 5, okay? But check this one out. What if I do this? P2 dot X equal 10. I can do that too. I can reassign X, okay? And if I do that and I print P1.x, might as well just print P2.x too, okay? What do you think will happen? I want you to try first and see if it makes sense or not. Let's see if it makes sense. Let's see more now. นี่ครับเดี๋ยวเลิกทุ่มหนึ่งแน่นอนนะครับอันนี้มา IM ใช่ไหมครับเดี๋ยวเลิกทุ่มนะครับใจเย็นรู้แล้วว่าต้องเลิกทุ่มครับ Okay? I don't know if you expect this, but you get 5 and 10. Got it? Did it make sense or did it not make sense? It's like whatever. I don't care. This is too late at night. I think that's the last one, but never mind. Okay. The reason that you get 5 and 10 is that whenever you create an instance of the class, it owns that variable. Like P1.x, that's whatever belongs to P1, right? And then when you create the P2 object, it has its own X, right? It X equal to 5, right? So when you create both of them, both X equal to 5. But then when you start to reassign or change the variable of P2, X.x, right? That's only local to P2. So P2 owns its own X. When its X change, doesn't mean that P1.x will change because it has separate things, because it has its own thing. Okay, so that's why you can have this kind of occurrence. Okay, so it's very nice to program with classes because you can define a lot of things that your instance would own. For example, a model in machine learning usually has lots and lots of parameters. So each model that you define will have its own copy of the parameter, and you can change one without affecting another. It's pretty nice, and it works for all of the things that you're going to do, all the library that you're going to use based on the class definition. So you don't create it per se, but you are going to use it. So That's why I'm telling you right now, okay? Okay, so another thing is constructor. So that's kind of the big thing in here, okay? So right now my class is very, very simple, and every object that get creating from it will get the x that equal to 5. But that's too limiting, right? I don't want my class to always have x equal to 5. I want x to be more flexible, right? So that's the job for the constructor, okay? So the constructor is a special function that get called when you create that class. Okay, so let me show you. It might look a bit complex, but to tell you the truth, that's just what it is. Okay, you just have to know it, and that's all. Okay, so I'm gonna create another class called person. Okay, but this time I don't want to do. So let's say person will have name and age, right? If I were to do this, name equal Tom, then that means that every person that I ever created from now on will get the same name, which is kind of bonkers, right? So I want person to be more flexible. So I want a constructor. A constructor is a function that has a specific name called underscore underscore init underscore underscore, like that. That's required, okay? So don't ask. It's called the magic function. Okay, there are many types of magic functions in here. One of them is a constructor, okay? In here, you are getting one special argument called self. And I'm not sure about you, but when I first learned about class, the self concept is one of the most confusing thing ever. As far as I remember. I don't know if it's for you or not, but let me try to explain what self is, okay? Wow, that's dramatic, okay? Self is whatever that new object is. Remember, this is the definition, right? Definition is used to create a tangible object. When you call this function, right, you get access to the newly created object, and you can do whatever with it. That's the job for the constructor. And what I mean by doing whatever is to set whatever the value that you want, okay? So after the self, okay, I'm gonna say that I want name and I want age. But keep in mind that whatever I put in here after the self, this one is gonna come from outside, okay? So this is very useful because I can set this thing from outside, okay? Okay, so in here, this is very, very typical. It might look weird, but all you have to do is just do it, okay? So I'm gonna say the newly object called self, like newly created object, dot the attribute or the data called name is gonna be equal to name, okay? Which is super confusing, right? And also, the self, which is the newly created object, dot age is going to be equal to age. Wow. What is this? Okay, let me explain. Okay. First, this function gives you access to the newly created object. Okay. And you are setting that object's attribute or data or x from the previous, I guess, equivalent to that x from the previous example. Self.name is called, each person is going to have attribute called name and age, okay? But then that value is going to be equal to whatever this is, okay? This is the same thing, and this is the same thing, okay? It's confusing because it's spelled the same, but actually there are different things, okay? So the red one is the notation for that particular data. So it's called attributes, okay? It's like x from the previous example. But this one on the right, this is the actual value, like 5, like 10. So this one comes from outside. Okay, so with this construct, each person will get his own name and age that you can set from outside. Okay. Again, you don't need to create your own class in this class, okay? but it's good to know where it comes from. Okay, so that when you call that constructor, call that class, you know what you're doing. That's all. That's all. I hope you're aware. That's all. Okay. So let's do this. All right. So once I create the person, and I can start. Once I create the construction for the person, class for blueprint for the person, I can do the instance of this class. So I'm going to say P1 equal person. Okay. But this time I cannot just do this, because if I do this, I will get error. See? It's going to say that, wait, okay, I need to run this one. Run, and then run this. Okay. It will say that right now I'm missing a name and age, right? And that's exactly what I do here, because I'm saying that if I want to create a new person, I need this information from outside. But then when I actually creating that, I didn't give them anything. So I need to input two things from out so that it can do its job. Okay. So I need to do name, which is Tom. Okay. And age is 30. Okay. And now I can do this. And then once I do this, then the cool thing is that P1 dot. Now you can see that the VS Code is smart enough to know that there are two information or attributes relating to this object. And I can access it however I want, right? I can do P1.age. I can print, okay? P1.age. I can print P1.name. Okay, I can do that, right? And I can even create another person with different information like Sarah, age 20. I can print P2.name, print, okay, P2.age. Okay, I can get its own, information. And I can even change things independently, right? I can change the age of Sarah to be 100. And then if I print P1.age and I print P2.age, then again, each person get his own data, basically get his own personal information. And I can change one without affecting the other two. Okay, so that's basically what you're doing afterward when you start using the library. Okay. Unknowingly, okay, unknowingly. Okay, I have 7 minutes. Okay, I can go through one more concept, which is called methods. Okay, and that's going to tie into whatever we learned at the beginning, hopefully. Okay, so in addition to the data, which is called the attributes, person or class can have action. Okay, we talk about action a lot, right? Class can have action. Okay, so let's do some action. Okay, so in here, let's say method. Okay, so I'm going to copy. Let me just copy because it takes some time to write. Okay, so I'm going to copy it here. Okay, so again, the same person class, right? But this time, I want person to be able to do some action. And exactly what that action is a function. So I'm going to say def, right? But now I have another function called myfunc. Okay, fine, myfunc. Okay. I think I want to change it to say hello. I think it makes more sense. Okay. In my example, I had something else. So, okay. Again, action is function. So this function, I want this person to be able to say hello, right? And again, this one, I also get a special access to self again. Okay, I can do self in here. Okay. Okay. And it's kind of weird, but all the functions that you define in the class will get access to the self keyword. And self is actually the access to its own object, right? And the reason that I want this one is this. I will show you this, okay? So if I want to say hello, then I want to do this. Print, right? I will say hello, right? But then I want to say my name too, right? If I want to say hello, my name is Tom, right? Let's say the person is going to be named Tom. And I hard code this, like hello, my name is Tom, right? You can imagine that like all the person that you're going to create afterward is going to say the same thing, which is wrong, right? Like each person has his own name. So this is where the self keyword becomes useful because each person has his own name, right? So I want to access the person's name and I can access through the self keyword. So that self actually points it back to that particular object. So I can access that object's attributes, okay? So I can say like my name is, but now I want to do this, plus self.name. And you can be sure that whatever that name is, it's going to be the same as this one, which comes from this one, where we put it in when we construct that person, okay? And with this construct, it's pretty cool, right? You can say this. I can say P3 equal to person. I want to create name equal to Tom, and then age 30, whatever. But then I want to do P4 equal person, Sarah, right? And then I want to do 20, right? And now if I do P3 dot say hello, remember this? This is very similar to what I said in the beginning where I was telling you that each object has an action, right? List you can do dot append, dictionary can do dot item. This is exactly the same thing. P3 can say hello exactly because we already did it in the class. And that's what Python do behind the scene. Same thing, okay? So I can say P3 say hello, P4 say hello, and now each person is going to say his own thing, like that, okay? Okay, this is kind of fast. So next time I'll revisit this concept again, okay? Thank you. But don't forget to do the homework. And I realize that the homework might be a bit too much, so I will reduce the amount. So stay tuned. Okay, so right now, I think it might be too much for you guys. So I'll cut down half of it. So you just need to do half of it. Because if I give you too much, you're going to do AI anyway. So might as well just give you just enough. But I want you to do it on your own. That's my take on it, okay? See you after the midterm. Okay, good luck with the midterm. And the midterm does not include my stuff, only include Ajahn Neu's stuff. I think she might have told you this, but my stuff will not be in the midterm, okay? So have fun and good luck, okay? Okay, guys, we need to